Hi guys, welcome to Tech Geek. So today we'll be discussing the daily LeetCode challenge problem for the day. That's binary tree right side view. So that's the LeetCode medium 199 version. I guess if my voice isn't clear, then please do pardon me for a time because I'm not well. I'm still trying to share this for you guys. Okay, so before beginning, I'd just like to request you all if there's anything you'd like to know from me for any upcoming placement session, any interview questions, or some company important questions that are to be asked, that's a help sheet, anything like that, do let me know in the comment box. I've shared a Telegram channel link to you can even ask me there if there's something you'd like to know. And not just this, for the batch of 2022 and 2023, I am running a placement session series, so please look there, have a look how to do it. And for the ones who have just begun in college, go through the DSA roadmap and some sheets by some great content creators I've shared, so you can refer to that. Okay. Let's get back to the question. What does it say? So we have been given a root of a binary tree. Okay. We have to imagine yourself standing on the right side of the tree. Return the values of the nodes you can see, ordered from top to bottom. Let's see, this is a tree. A person is standing somewhere here. So if the person is standing somewhere here, obviously the thing that he would be able to see, okay, the person who would be able to see just the points where he's standing. So if he's standing on right, he'll be able to see only the right sided elements. If the person is on the left, on the left side. So this is the right view of the tree. Okay, so we have to get the right view. Okay, I hope that's clear. Like, what's the meaning of right view? Let's say if the person is standing here, then in that case the person will be able to see only the first upcoming series of the boundaries. So if we talk about right view, that means the right boundary. Okay, now talking about the right boundary too, let's say if we have a tree something like this. Okay, one like this. If in this case we talk about there's no children to the right, so this time the right view will comprise of this also. Why? Because from there, from the right side, the first node that comes up, we have to take until there. Okay, so that's what they have given some examples to. This is actually the tree they were talking about. So 1, 3 and 4 should be the output for such tree. So that's how we need to go. Now comes to the problem, like how should we approach this, right? Let's say this is a complete binary tree for now we have, and we have to go up with its solution. Like we have to give its right view. If you talk about without any queries or anything, we know what would be the right view. First of all, the root will come. Coming to the second, again, the last one, that's the right side node. 3 will come. Again, come to the next level, the right side node, 7. So for this, the answer would be 1, 3 and 7. Now let's see one thing. What if there was another node that's like this? If there's another node like this, then obviously this will also be counted in the right view. Why? Because for this level, the rightmost node was this, right? So what we have to do, we have to do the level order traversal. Okay, you can see we did a level order traversal one by one. In each level, we took the last node. Okay, because while doing level order traversal, we'll go this way. We'll take the last one. Okay, you could also say that we can directly call the right ones. Okay, iska right subtree, then right subtree, then right subtree. No, that won't work. Why? Because if you talk about this case, if it was until here, this would work in somehow. But if you talk about cases like these, then it won't work. There could be a case where we don't have the 7. Okay. then in that case 6 should be included, right? So this is how things could be. So that's what you need to know. Now you know how you have to do. You have to take a level order traversal. In that level order traversal, take each level you have to check the last node. Okay. So how we will do this? Okay, before beginning, just a second, I'd like to request you all that please don't go up with the solution. Just go for the approach, try yourself, because that's what will help you out. There won't be a question that would be asked directly. There could be a type of question or a modified version for the same question. So it's better if you guys try it on your own. That will improve your productivity. Okay, so that's what matters to me. I don't want to gain views, I don't want to gain more of subscribers, but I just want to help you out with this. That's what my basic motive is. So please don't try to copy paste, because in the coming days when you will be appearing for the interviews, this could be a negative point in your growth. Okay. Now let's get back to the solution. We know how we have to do now. Let's see how we'll approach this. Okay. First of all, the condition that comes up is the base condition. The base condition says, is the root null? No, it's not. If the root is null, obviously we'll return an empty list. Okay. And we'll create a list where we'll be adding up these elements, because in our solution we are required to return a list. Okay. Now, we'll take a node, that's a queue for the nodes. Initially, in the first level, we should add this root, because for every tree we'll be having a root. Once we have added the root, we'll come to the next levels. So what we'll do, we'll check if the queue is not empty. Until the queue is not empty, we'll check for this. Now we'll take the size. What will the size tell? The number of elements in that particular level. And for particular level, we'll run a for loop, and until we get the last element. Okay, until we get the last element, we won't print it. And for each element in this, we'll be calling its left and right subtree. Okay, what I'll just give you a go through of this. Let's say we are in loop 1, we enter the while loop, we just have one element. So for here we just have one element. We printed, let's take this list version also. This is a list. We added this to the list, and this is the queue. Now once we have finished this work, so we'll remove this. This was a current node, okay, where we are working right now. We'll check if currents left is not null. Okay, add this to queue. Same here, if currents right is not null, add this to. No. Again checking, is the queue empty? No. Now queue size is again 2. Come to the for loop. Now current will point here. Okay. Current points here. Again check. Is it equal to n minus 1? No. So we won't store this one. But yeah, we'll add this 4 and 5 here. Why? Because of the recursive call of adding its left and right elements. Okay. Same for here. Now, if we come to 3, is it n minus 1? Yeah. Take this and do add its, I'll just add it here, left and right elements. And while adding the left and right elements, you guys have to remove the first and second element. Coming to 4, again you will add up 8. 4 is not n minus 1, it won't work. Remove 4. Coming to 5, is 5, so for n minus 1, this was the fourth node. So fourth node, is it? No. 6, is it a fourth node? No. And do we have anything? No, there none. For 7, yes, that is. So we will take 7 here. Again coming to 8. Yeah. For 8 now, if 8 is current, is its left and right node null? Yes. For this level, okay, the size for the queue is again 1. So is it equal to the same value? Yes, it is. So add this. So this is how we guys have to approach the problem. Take a queue. This is just a general question. But if we talk about the complexity, So the complexity for this particular problem is that we are going to each and every node at least once, right? We are visiting these nodes at least once, as you can see. So for this, our solution will be order of n time complexity. And if you talk about the auxiliary space or the space complexity, then too it's order of n because we're using a queue, and that queue is storing these n elements. Okay. So this is the time complexity for us, and this is the space complexity. I hope the solution was clear. If in case it was not, then do let me know. I'll be creating a video for the two views, that's right view and left view, differently explaining various approaches. So stay tuned for the same. Let's have a look at the solution. We'll just go through easily. We create a list, checked if it's null, return the empty list, create a queue. If queue is empty, if queue is not empty, we'll run this recursively. Then it will store the number of nodes in each level, traverse each level, find the peak, current should point to the peak, remove it. If it's the last node of each level, print it. If not, then we'll add it to the queue, and that's the left and the right, and at last we return the list that we have. So I guess that's just an easy thing that we explain. So if in case you have any queries, do let me know. Anything that pops up in your mind, any queries, any particular thing, then do let me know. Thank you so much.